It's so good now. How are you doing?
I'm doing great, and you?
I'm also doing great.
So, should we start?
Let us let us start.
Okay, so the last class,
Okay.
we talked about electricity, and now I am going to summarize electricity. So let's start. Okay, this is kind of frozen. Wait a second. Okay. When a bunch of atoms are together and electrons are moving from one atom to the other in the same direction, this is called electricity. So see, from
I
this
see.
atom to this atom, from this atom to this atom. For example, you get the electron and you pass an electron, and the other atom passes the electrons, and then the other atom gets the electron, passes the electron.
Okay.
It's like that. See, shortly, electricity is a flow of electrons. When electrons are pushed and pulled from atom to atom, electricity results. Electricity happens.
Okay.
Okay, so with that electricity, let's learn static electricity. A static charge happens when two surfaces touch each other and the electrons move from one object to another. One of the objects will have a positive charge and the other will have a negative charge. So can you see here? The positive charge is this one, and negative charge is this one. And yes. Why is your microphone mute?
I'm coughing. Oi, what's happening to me? I'm good. Let's continue.
I
Let's
think
continue.
when you drink your coffee or whatever you're drinking, you drink it and it 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 stuck in your throat, and you started cough to get coffee droplet out of your body.
Yeah, sometimes that happens too. This was slightly different.
Yep.
This was more of an itch.
Static
And
electricity happens
okay.
actually a static charge happens. Right, static charge. A static charge happens when two surfaces touch each other. See, like this. And the electrons move from one object to another. For
Okay.
example, yes.
For example, which ones? 1 minute.
So for example, this is my atom and my electron, and this is the second atom. and its electron.
Okay.
I'm gonna put this atom's electron because it's always sticking into me. So here's the electron. Whoops. And the electron moves here from here.
Okay. From here to here.
Yes.
Okay.
One object to the other. Another. And the one object will have a positive charge and the other will have a negative charge. So let me say something. There are conductive materials and non-conductive materials. I'm going to tell you something about that.
All right.
And conductive materials, we call them conductors. Conductive materials is a material or object which allows electricity or heat to travel around it or through it. For example, silver, copper, gold, aluminium, iron, steel, bronze. And non-conductive materials, we call them insulator.
Okay.
Insulator, which for the second name is non-conductive materials, is a material or object which does not allow electricity or heat to pass through it. For example, glass, rubber, porcelain. How do you pronounce that? Porcelain.
Yes.
Ceramic and plastic. These are insulators.
Wait, what about wood? Where does it fall?
Let me check it.
Okay. I'm thinking of things around my house. I have plastic, glass.
Wood is a natural insulator.
Okay.
Insulator.
Non-conductive.
It's non-conductive, yes. Insulator. Next one. For example, if there are more protons than electrons, then an atom is said to be positively charged. If there are more electrons than protons, then it is said to be negatively charged. If an atom has the same number of electrons and protons, then the atom has a neutral charge. So it has 6 positive charges and 6 negative charges. Then what would it be? Would it be a positively charged atom or negatively or neutral?
It has 6 positive and 6 negative. It would be neutral.
Yep, you're right. If it has 6 positive, 4 negative, what would it be?
It would be positively charged.
Yes. And my last question. 6 positive, 9 negative, what would it be?
6 positive, 9 negative. It would be negatively charged.
Yep, you're right.
Okay.
You're correct. All correct.
All right.
Star for Moureen.
Thank
A
you.
star for Moureen.
Thank you.
Items with different charts, positive and negative, will attract each other. It means pull each other, like magnets. While items with similar charges, positive and positive, will push away from each other. So a magnet has north. This is my magnets, for example. This is north, and this is north. They would push each other. They wouldn't be.
Push. 1 minute. If it's negative and
They
negative,
would.
what
They
do they?
would push each other.
They push each other away.
Push each.
All right.
And if they are south and north, they would pull each other. This is in magnets.
Pull towards each other.
Yep.
All right.
It's kind of like magnet, as I say.
Okay.
So, do you know anything that, for example, this positive and negative push each other, pull each other, and positive and positive push each other. So it's kind of like magnets. What else is similar to this?
Electricity.
Electricity?
Static electricity. Not?
Similar. This, but I said different from magnets and static electricity.
Besides static electricity,
Besides
magnets.
Besides them.
I think this is different from humans. Humans are different.
What is this like? So magnets, north and north, push them, and south and north pull them. So it's kind of like magnet.
Okay.
And what else is it like besides static electricity and magnets?
I have no idea.
Do you know anything?
No. What else?
Yeah, me too.
This rule. You also don't know any? What about humans?
Anyways.
Can I have a question? What about humans?
Nope.
I think they're the opposite of this. If people are similar in character, they become friends. If they're not similar in character,
they can touch each other whenever they want.
No, I mean in friendship.
Oh.
Yeah.
So.
Okay.
Let me stop this. So I have a GIF here for some example.
Okay.
Example here. So for example here, positive and negative. The positive pulls the negative. See?
Yes.
And the man here tried to make the positive and positive pull each other, but it didn't work.
Okay.
They pushed away. The
So
positive pushed away the other positive. Yes. Oops. So you have gone flying down a slide and your hair stands straight up. This is because of the friction effect of sliding. It has caused a positive charge on each piece of hair. As I mentioned, positive and positive not pull each other, they push each other.
All right. So they repel.
So every hair piece has a positive charge. So it means they stand up and do a fight. They push each other. It's like a fight.
All right.
As each hair has the same charge, they all try and push away from each other, causing that funny straight hair to stand right up. Look at this boy. He looks so funny.
His hair looks really funny.
Like,
yes.
anyways, have you ever rubbed your feet across carpet and then touched a metal door handle? If so, then you know that you can get shocked.
Many times I've gotten shocked, but I didn't know why and how it had happened. I just felt like, oh, there is electricity, and I generally get my sleeves like this and try to open the door. I didn't know it was because I had created static electricity. Now I know.
Anyways,
Mm-hmm.
now I have a experiment.
All right.
So, the things we need.
Okay.
A cotton towel. Plastic.
Can it have a wet? Can it be a wet?
Nope. This kind of towel. No, not scissors. You are going to cut this, and it needs to be thin, not thick.
What's that?
And I cut this from a plastic bag.
Okay.
And you need a balloon.
A balloon. Right.
Yes, let me show.
I have a balloon.
Please, a balloon. Anyways, let me show you how it works.
All right.
So first, you get the towel, or if you don't have a towel, you can just rub it on your hair. So you rub it.
1 minute again. I'm gonna go get a balloon. I think I have a balloon.
Okay.
Somewhere. 1 minute. But it will
if it's not full with air, you can fill it with air. I'm waiting.
I'm back. I have this, but it's a very tiny balloon. I hope I can blow air into it. So you can tell me what we are going to do while I blow air into my balloon.
So first, we are going to rub the towel or our balloon to our hair like this for a little.
Oh, we need a... Can I rub it onto my cloth?
I think you can rub it onto your hair.
Okay, 1 minute.
Okay, that's enough. Now, this.
And then?
And then you get the plastic bag, cut it, and do this. See?
I have a plastic bag.
Then you get the balloon.
All right.
And it has to flow. I couldn't do it. Wait a second. I need to. It's sticking to me. Ah! was floating. It's sticking to me. Oh, it floated.
It's floating. I do not have a plastic bag around me. How come? This is very huge. It won't help. I'm just gonna watch yours.
Then needs to. It's floating. It was floating. It's sticking
What is
to
it
me.
supposed to do?
Oh, it's floating. Can you see that? It was floating.
Yes, I did.
It's sticking to me. It's following my shoulder. Oh, it's following my. Let's see. It's just on my shoulder. Okay, I'm gonna get that static electricity away. Okay, I got the static electricity away.
All right.
Now I have a video that it's actually really is amazing. So let me share my share your sound. Wait a second.
All right.
To start the sound. Okay. Music. Yeah. Oh. Okay. Now we're going to watch this. Wait a second. Am I sharing the sound? Let me share the sound.
All right.
Can you hear it?
Yes, I can.
Okay. Really like magic and amazing. Try to.
I think you have to rub the piece of cloth for a long period of time.
Not long. We did it long, but it didn't float it.
Did you rub the piece of cloth to the polythene bag?
Yes.
And it failed?
Anyways, let me share my screen.
All right.
So, how does it work? When you rub the towel against the balloon and plastic band, this transfers a negative charge to both objects. The band floats above the balloon because the charges are the same and will work against each other and not be attracted to one another. When you rub a balloon on someone's hair, it picks up electrons, which levels it's negatively charged, and the hair is positively charged. Opposite charges attract, so when you take the balloon closer to the hair, it will stand up and trying to get the charge in the balloon. This is what exactly the man did.
Cool science
So
experiment.
anyways, our lesson time is finished. Let me just summarize quickly.
Right.
We summarized electricity. We started static electricity and we finished static electricity. We are learning lightning in the next class. We did an experiment which was very fun.
It was.
You can do this experiment.
I'm going to try it again. I'll let you.
I am going to send the link.
Okay.
I'm going to send the link to the chat box. Find it.
Where have you sent it?
Come here.
In
You see it?
Zoom chat. 1 minute. Should right? Oh, yes, yes, I can see it. Great, thank you so much.
And open it from there. Anyways, Moureen, goodbye.
Goodbye, I can see you. Let me know if you try the
Bye-bye.
experiment and it can float. All right?
It actually floats. We tried it before class and it floated
Ah,
for
all right. I'm also
like
gonna
2 seconds
try it and see
first.
if it can float. Goodbye.
Anyways, bye.
See you.